I want you to do something for me. Just for a second. Look down at the floor. Or, the ground, if you're walking. It looks pretty solid, right?
All moving. Reliable.
Totally. If you put a coffee cup down, it stays there. We build our houses, our cities, our entire lives on this assumption that the ground is just there. Static.
Which is a very comforting illusion, but it's an illusion nonetheless.
Exactly. Because if we zoom out, way, way out, that static ground is actually this jagged crust floating on a kind of molten slush puppy, spinning at 1,000 miles an hour while it's hurtling around a giant ball of burning gas.
And that thin crust is covered in a film of water and wrapped in this really delicate bubble of air.
And that right there is the difference between seeing the Earth as just a rock and seeing it as a system.
A living system.
A dynamic breathing system. And today, we are going to tear that system apart. We are looking at the places where land, water, and air collide to create the only thing that, actually matters to us, life.
It sounds quite poetic when you put it that way, but this is actually hard science. This is the foundation of physical geography.
And for our specific audience today, this is the difference between passing and failing. We aren't just here to admire the view. We are here to answer some of the toughest questions in the civil services examination.
That's the mission, isn't it? We are taking the NCERT Class 6 Geography Chapter 5, Major Domains of the Earth, and we are going to squeeze every single ounce of value out of it.
But wait, I can hear the listener thinking it right now. Class 6, seriously. I'm preparing to be a diplomat, not a middle schooler.
I get that reaction a lot. I really do. But here's the thing. The NCERT, it provides the vocabulary. The UPSC provides the application.
Okay, so what do you mean by that?
Well, if you don't understand the basic vocabulary of the lithosphere or the hydrosphere, you have absolutely no chance of answering a high-level question about, say, geopolitical strategy in the Indian Ocean or climate change protocols.
So we are going to bridge that gap. We're going to take this simple text and link it directly to high-level previous year questions, or PYQs. We'll show you how a sentence in a 6th grade book actually evolves into a question that could determine your entire career.
It's all about building a mental model. We aren't just memorizing facts. We're trying to understand how the machine works.
Okay, before we start dissecting the planet, we have to acknowledge the engine running this whole ship. This deep dive is explicitly a full summary for UPSC, focused by Simplified UPSC by PPT YouTube channel with PYQ linkage.
That is a bit of a mouthful, but it's the channel making this deep analysis possible.
It is. And look, I'm just going to be honest with you. We put a ridiculous amount of work into these deep dives. We're synthesizing textbooks, exam papers, expert analysis.
It's a lot.
It's a huge amount of work. So if you are getting value out of this, if you're finding that these sessions are helping you retain information better than just, staring at a book, please, I'm humbly asking, subscribe to the Simplified UPSC by PPP YouTube channel.
It really does help with the algorithm. YouTube retention is a beast, and your subscription really helps tame it.
And beyond just the algorithm, there is the reality of production costs. So if you are capable, and please, only if you are capable, consider supporting the show on Patreon. It just ensures the team can keep bringing this super useful content to you without us having to, sell out to match our sponsors.
And a massive shout out to all of our current supporters. You know who you are. You guys are the bedrock, the lithosphere, if you will, of this entire operation.
Nice one. Also, engage with us. Like the video, leave a comment. Tell us if we're going too fast, too slow, or if my jokes are actually landing. We read every single one.
And what about the notes? People always ask about notes.
Right. Good point. You don't need to be frantically scribbling while you're driving or cooking. We have free notes with practice PYQs, all available on the public Telegram channel.
But for the power users, the really serious learners.
For the serious learners, yes, we have premium access. If you want to access all the videos of this series at once, along with the premium notes, which include detailed notes, extra PYQs, and model mains answers, all organized perfectly, you need to join our private Telegram library.
And how do they do that?
Just DM us on the public channel. It's that simple.
Okay, housekeeping handled. Let's get back to the Earth.
Let's do it. We are breaking this down into the 4 major domains: the lithosphere, which is land;
The hydrosphere, water;
the atmosphere, which is air;
and the biosphere, life.
It seems like a simple categorization, but I have a feeling the boundaries are going to get very, very blurry.
Oh, they do. That's where the interesting stuff happens.
Okay, let's start with the ground beneath our feet. The lithosphere.
The term itself comes from the Greek lithos, which means stone. And the textbook definition is pretty simple. It is the solid portion of the Earth.
Solid portion. But here's my first question. Is it just rock? Because if I go outside and start digging, I hit dirt. Is dirt part of the lithosphere?
Yes, absolutely. That's a great question. The lithosphere comprises two main things: the rocks of the Earth's crust and these thin layers of soil. And that soil part is critical. The text specifically says it contains nutrient elements which sustain organisms.
Ah, okay. So without that soil layer, the lithosphere is just a dead planet, like Mars or something.
Exactly. The soil is the interface. It's the bridge between the dead rock and the living biology.
Now, the source material gives us this map. It's figure 5.1 in the text. It divides the world into two main camps: the large land masses, which we call continents.
And the huge water bodies, the ocean basins.
And this is where the text throws a bit of a curveball. It states really clearly that all the oceans of the world are connected with one another.
Right. If you get in a boat, theoretically you can sail anywhere without ever touching land. One big global ocean.
Right. But then it asks this question: are all land masses connected with one another?
And visually, on a map, the answer is obviously no. You have the Americas separated from Afro-Eurasia, and then you've got Australia and Antarctica just sitting out there by themselves.
But geologically, under the water.
Geologically, under the water, the crust is continuous, yeah. But functionally, and this is what's important for, say, the migration of land animals or for early human history, they are disconnected. This separation is what allowed different ecosystems and, different civilizations to develop in total isolation for thousands of years.
Okay, now here is a concept that always confused me a little bit in school: sea level. Why do we measure everything from sea level? Why is that the 0 point?
It's all about having a consistent baseline. Land is bumpy, right? Goes up and down, mountains, valleys, but water seeks its own level.
Okay.
The text explains that the level of seawater remains the same everywhere.
Because of gravity pulling it down evenly.
Exactly. Gravity pulls the water toward the center of the Earth, creating this relatively smooth surface, it's technically called the geoid, that wraps around the entire planet. So whether you're in Mumbai or you're in New York, 0 is the same reference point for everyone.
Which allows us to measure the extremes. The source highlights the highest point, which I think we all know.
Mount Everest, 8,848 meters above sea level.
And the lowest point, which is just terrifying to think about, the Mariana Trench in the Pacific Ocean, it's 11,022 meters deep.
I want you to just pause and visualize that for a second. 11 kilometers straight down.
So if you could somehow cut Mount Everest off at the base and just drop it into the Mariana Trench, it would sink.
It would completely sink, and you'd still have over 2 kilometers of water above the peak.
That is just, it's hard to get your head around that scale.
It really is. It creates a deep sense of scale. The roughness of the Earth, the difference between the highest peak and deepest trench, is about 20 kilometers, which sounds like a lot to us, but on a planet that's, 12,000 kilometers wide?
Nothing.
It's smoother than a billiard ball, proportionally.
That's a humbling thought. So we are just crawling around on the fuzz of a billiard ball.
Essentially, yes.
All right, let's take a tour of the fuzz then. The continents. There are 7 of them. Now, I don't want to just list facts like we're reading a table. I want to look at these through the lens of a strategist or, a geographer. Let's start with the big one, Asia.
Asia is the heavyweight, no question. It covers about 1/3 of the total land area of the Earth.
1/3. That explains a lot, like why it has the most people.
It lies in the Eastern Hemisphere, and a key geographic marker, one to remember for the exams, is that the Tropic of Cancer passes right through it. This means the southern part is tropical, while the northern part stretches way, way up into the frozen Arctic.
The source also mentions it is separated from Europe by the Ural Mountains on the west.
And this is a really crucial point for critical thinking. The continent of Europe and the continent of Asia are actually one single continuous landmass called Eurasia. The Ural Mountains are not a vast ocean. They are just a mountain range. The division is actually more historical and cultural than it is physical.
So, geographically speaking, Europe is basically just a big peninsula sticking out of Asia.
That's one very good way to look at it.
Yeah.
But in the textbook definition, they are separate. And speaking of Europe, it's much, much smaller. It's bound by water on 3 sides. You got the Arctic Ocean, the Atlantic, and the Mediterranean. The Arctic Circle passes through it, so it's generally temperate to cold.
Okay, let's go south. Africa. This continent is, well, it's geographically bizarre in the best possible way.
It is completely unique. It's the second largest continent. But here is the exam-winning fact, the one you absolutely need to know. It is the only continent where the equator, the Tropic of Cancer, and the Tropic of Capricorn all pass through.
Wait, hold on. Let's unpack the implications of that. if you have the equator running through the middle and then the tropics on both sides?
It means Africa is essentially a mirror image of itself, climatically speaking. You have rainforests in the center, right at the equator. As you move north from there, it gets drier and drier until you hit the Sahara Desert, the world's largest hot desert.
And if you go south?
Same thing, as you move south from the equator, it gets drier until you hit the Kalahari Desert.
So it's symmetrical climate zones. That's fascinating.
Roughly, yes.
Right.
And it's bound on all sides by oceans and seas. It's a massive island, really.
And it also hosts the world's longest river, the Nile. I see the text makes a distinction. Longest, not largest.
Correct. That's a key distinction. The Nile flows south to north. There's another interesting geographic quirk, and it empties into the Mediterranean. This river was the absolute lifeblood of ancient civilizations because it brought water right through that massive desert we just mentioned.
Okay, let's cross the Atlantic. North America.
Third largest. It lies entirely in the northern and western hemispheres.
The connection point is key here, isn't it?
Yeah.
The Isthmus of Panama.
A very narrow strip of land. This is incredibly important from a strategic point of view. If that strip of land didn't exist, the Atlantic and Pacific Oceans would just flow into each other naturally.
Uh-huh.
Because it does exist, we had to build the Panama Canal to connect them.
And that isthmus connects it to South America.
Right. South America is mostly in the southern hemisphere. It has two geographical heavy hitters mentioned in the text. First, the Andes, the world's longest mountain range.
That runs all the way down the west coast, right? Like a spine holding the continent up.
Exactly like a spine. And then you have the Amazon, the world's largest river.
Largest meaning in terms of volume of water?
Yes. The sheer amount of water the Amazon pushes out into the Atlantic Ocean is just staggering. It's more than the next 7 largest rivers in the world combined.
Wow. Then we have the outlier, Australia.
The smallest continent. They call it the island continent. It's entirely in the southern hemisphere. And because it's so isolated by oceans, its biology, its biosphere, evolved completely differently from the rest of the world.
Which is why you have kangaroos and koalas there and basically nowhere else.
Precisely.
And finally, the frozen wasteland, Antarctica.
It's huge, larger than Europe and Australia combined, but it's permanently covered in these incredibly thick ice sheets because the South Pole is located right at its center.
And the text makes a point of saying there are no permanent human settlements.
No cities, no towns, just research stations. It's a continent that's been dedicated entirely to science by international treaty.
And for our Indian listeners, the source specifically names India's stations there. This is important to remember.
Yes, Maitri and Dakshin Gangotri. You need to know these names. Dakshin Gangotri was the first, but it's now buried in ice and abandoned. Maitri is still active. And there's a newer one, Tarati. Though the Class 6 NCERT might not be updated that fast, you should definitely know it exists.
Okay, that's the tour. But as we promised, this isn't just a travelogue. Let's put on our simplified UPSC hats. How does this continent is here information link to the high-level exams?
Right. This is where we pivot from the what to the why. Let's look at the 2013 preliminary exam. Question 18. It asks about the factors that are responsible for bringing dynamic changes on the surface of the Earth.
Okay, so the NCERT chapter paints this picture of continents as these stable, static puzzle pieces. But the exam is asking about change. What makes them move?
Exactly. The question lists a bunch of options like electromagnetic radiation, geothermal energy, gravitational force, plate movements, rotation, and revolution.
And the correct answer involves?
It involves plate movements and gravitational force.
Let's break that down. Plate movements, what does that mean?
Well, the lithosphere isn't one solid shell. It's cracked, like a broken eggshell. These pieces, we call them tectonic plates, are constantly moving.
And why are they moving?
Because the layer underneath the mantle is hot, and it's churning. It's like a conveyor belt that drags the plates around on top of it.
So when we read in the NCERT that Asia is separated from Europe by the Ural Mountains or the Himalayas are in Asia, the UPSC perspective isn't just about locating them on a map. It's asking, how did they get there in the first place?
Precisely. The mountains mentioned in the text, the Himalayas, the Andes, the Rockies, these are all what we call fold mountains. Imagine you're pushing a rug against a wall. It wrinkles up. It folds. That's exactly what happens when two tectonic plates collide.
And there was a mains question about this, wasn't there, in the material?
Yes, 2016 mains question 17. Why are the world's fold mountain systems located along the margins of continents?
Oh, that connects perfectly. So the NCERT tells us where they are. You know, the Andes are on the edge of South America, the Rockies are on the edge of North America. The UPSC asks why they are there.
And the answer is plate tectonics. They are on the margins because that's where the collision is happening. That's where the rug is hitting the wall.
That turns a boring map into a kind of geological crime scene investigation. You're looking for the impact zones.
Exactly. And gravitational force, which is the other part of that 2013 question, is what drives erosion. Once the mountains go up, gravity immediately starts trying to pull them back down. Water flows downhill, glaciers slide downhill. That constant process is what shapes the landforms we see today.
So the lithosphere is a constant battleground between the internal heat of the Earth pushing things up and gravity trying to pull them back down.
That is a beautiful way to put it.
All right, let's move to the next domain. The hydrosphere, the blue planet.
Yes, and the source calls it the blue planet paradox.
A paradox usually means a contradiction. What's the contradiction here?
Well, the Earth is 71% water. From space, we look like this beautiful blue marble. But on the ground, we are constantly hearing about water crises, droughts, and scarcity.
So water everywhere, nor any drop to drink.
Samuel Taylor Coleridge was a geographer, it seems. The breakdown is right there in the text. 97.5% of all of Earth's water is in the oceans. It's saline. It's too salty for us to use.
Wow, 97.5%. So at least only 2.5% is fresh water.
But here's the kicker. Of that tiny 2.5%, the vast majority, almost 70% of it, is locked up in ice sheets in Antarctica and Greenland, or it's deep underground as groundwater.
So the amount of water that's actually available in rivers and lakes for us to drink and use is what?
Tiny.
A fraction of a percent. Less than 1% of all fresh water is easily accessible. That is why we can be a blue planet and still be incredibly thirsty.
Okay. Now, just like the lithosphere, the hydrosphere isn't static. The ocean basins are always in motion.
The text lists 3 chief movements: waves, tides, and ocean currents.
I want to bookmark ocean currents. I have a feeling we're going to come back to that because it sounds like a massive exam topic. But first, let's look at the containers, the big 5 oceans.
In order of size, you have the Pacific, the Atlantic, the Indian, the Southern, and the Arctic.
The Pacific is the monster. It covers 1/3 of the entire Earth.
It is. It's roughly circular in shape. It's surrounded by Asia, Australia, and North and South America. And as we already mentioned, it's home to the deepest point on Earth, the Mariana Trench. Then the Atlantic. This one is really interesting for trade and history.
It's S-shaped. You can see it on a map. It snakes between the Americas on one side and Europe, Africa on the other. But here is the little nugget from the text that leads directly to an exam question. The text says the coastline of the Atlantic is highly indented.
Indented. That just means it's jagged, right? Lots of ins and outs, bays and coves.
Yes. Think of the coast of Norway or the UK or New England. It's all broken up.
And why does that matter?
Because an indented coastline creates calm water. It creates natural shelters. If you were a ship captain caught in a storm, you can pull into a cove and be safe. It provides ideal locations for natural harbors and ports.
So you're saying it's easier to build a port on a jagged coastline than a smooth one?
Much easier. Look at a map of Africa. Much of its coastline is very smooth. If you want a major port there, you often have to build massive concrete walls, break waters to protect it from the waves. It's expensive and difficult.
So because the Atlantic is naturally jagged, it became the busiest ocean for commerce.
Partially, yes. Geography dictates economy. The ease of trade across the Atlantic is what facilitated the massive exchange between the Old World and the New World.
Okay, then we have the Indian Ocean.
The only ocean named after a country. That tells you a lot about India's historical maritime dominance in that region. Geographically, it's triangular in shape.
And the Southern Ocean.
That one encircles Antarctica. It's essentially the cold, churning, stormy water that connects the Pacific, Atlantic, and Indian Oceans at the bottom of the world.
And finally, the Arctic Ocean, sitting on top of the world.
Right. It's located within the Arctic Circle, and it's connected to the Pacific by the Bering Strait, a very shallow, narrow stretch of water between Russia and Alaska.
Let's do a deep dive analysis on the hydrosphere using the PYQs. I'm looking at the 2013 prelims paper again, question 54.
Ah, yes. The most important fishing grounds of the world are found in the regions where?
The options talk about rivers draining out or continental shelves, but the correct answer is warm and cold oceanic currents meet.
This is a classic application question. The NCERT tells you that ocean currents exist. The UPSC then asks, so what? Why should I care?
So why do fish care about currents meeting? What's the deal there?
It's all about food. It's a dinner bell. When a cold current, which is usually dense and nutrient-rich, meets a warm current, it creates turbulence. This churning action brings all those nutrients from the deep bottom of the ocean up to the sunlit surface.
And nutrients in the water means plankton.
And plankton means small fish, and small fish means big fish, and big fish means fishermen.
So if you look at a world map, where does this happen?
The most famous spots are off the coast of Japan, where the warm Kuroshio meets the cold Oyashio Current, and off the coast of Newfoundland, in Canada, where the warm Gulf Stream meets the cold Labrador Current. These are the legendary fishing grounds of the world.
And notice how this ties back to the Atlantic. You have the indented coastline, which is perfect for harbors, and you have these mixing currents, which are perfect for fish. It's just a recipe for a huge maritime economy.
Exactly. You cannot study the hydrosphere in isolation from economics or history.
All right, let's look up. We've done land, we've done water. Now the atmosphere, the blanket of air.
The atmosphere is absolutely integral. The book says it extends up to 1,600 kilometers, though almost all of the mass is very close to the ground. It provides the air we breathe, and crucially, it protects us from the harmful rays of the sun.
But it's not just one gas, right? It's a cocktail.
A very specific recipe. Nitrogen is the heavyweight at 78%. The text says it's essential for the growth of living organisms. Plants need it to build proteins.
Oxygen is 21%. That's our breath of life.
Right. That leaves just 1%. Mostly argon, but the text makes a special point to highlight carbon dioxide, or CO2. It's present in just trace amounts, about 0.04% now. But it does two critically important things.
One, plants need it for photosynthesis. That's basic biology.
And two, it absorbs heat that's radiated by the Earth.
The greenhouse effect.
Right. And here's a really crucial nuance that a lot of people miss. The greenhouse effect is a good thing. It's natural and necessary. Without CO2, Earth would be a frozen ball of ice. We need that blanket.
The problem, which we hear about constantly, is when the blanket gets too thick.
Exactly. Global warming isn't about the existence of the greenhouse effect. It's about the amplification of it by human activities.
Now, the structure of the atmosphere, it has layers.
Yes. Starting from the surface and going up, you have the troposphere, stratosphere, mesosphere, thermosphere, and exosphere.
Why do we need to know all the different layers?
Because different things happen in different layers. All of our weather, rain, clouds, storms, everything happens in the troposphere, the very bottom layer. But airplanes, they prefer to fly in the stratosphere.
And why is that?
Because it's calm. There's no weather up there. And, very importantly, it contains the ozone layer, which is what protects us from most of the sun's harmful UV radiation.
The text also makes a point about density.
Yes. Air isn't the same everywhere. It's very dense at sea level. The molecules are packed tightly together. As you go up, it thins out incredibly rapidly.
The source material uses a photo of a mountaineer to illustrate this point.
It's a perfect example. Climbers need oxygen cylinders on Everest, not because the percentage of oxygen changes, it's still 21% up there, but because the pressure is so low that there are just fewer molecules of everything, including oxygen, in every breath you take. Your lungs just can't grab enough to survive.
And this difference in pressure is what creates wind, right?
This is the fundamental rule of meteorology. It's very simple. Air moves from an area of high pressure to an area of low pressure, and that moving air is what we call wind.
Like letting the air out of a balloon. Inside is high pressure. You let the nozzle go, the air rushes out to the low pressure of the room. That's wind.
That's a perfect analogy.
Yeah.
And on a global scale, the equator is hot, which creates low pressure, and the poles are cold, which creates high pressure. So air is constantly trying to move to balance that difference out.
Okay, let's link this to the exams. I'm seeing a 2014 prelims question here regarding tropical cyclones.
Cyclones are, in essence, massive, violent, rotating low-pressure systems. To form one, you need a perfect storm of conditions from two different domains. You need the atmosphere.
So instability, wind.
Yes. And you need the hydrosphere. Specifically, a warm sea surface temperature above 27 degrees Celsius.
So you need the domains working together to create this monster.
Always. You can't have one without the other. And look at the 2016 mains question, Q16, about El Nino. It asks if most of the unusual climatic happenings are explained as an outcome of the El Nino effect.
El Nino. That's that weird warming of the Pacific Ocean, right?
It is, but it's a complex interaction. The ocean currents, which are part of the hydrosphere in the Pacific, they either reverse or slow down. This change in the ocean then changes the atmospheric pressure and the wind patterns the atmosphere above the ocean.
That messes everything up.
It's just the rain patterns globally. Suddenly, Peru gets catastrophic floods, while India and Australia get devastating droughts.
So you can't possibly understand a phenomenon like El Nino if you don't understand the basics from Chapter 5. That air moves, water moves, and they are constantly talking to each other.
Precisely. The heat zones mentioned in the source, the torrid, temperate, and frigid zones, they drive the global wind circulation. That circulation then drives the ocean currents. It's all one big, interconnected engine, and if one gear slips like it does during an El Niño, the whole machine shudders.
That brings us perfectly to the final domain, the one that combines all of them, the biosphere.
The domain of life. The text defines it as the narrow zone of contact where land, water, and air interact.
I love that description, narrow zone. If you dig too deep into the ground, it's too hot for life. If you go too high into the atmosphere, it's too cold and there's no air. We live in this incredibly thin skin on the surface of the planet.
And in this zone, all organisms are linked to each other and to the physical environment. This is the science of ecology.
The source mentions the two main kingdoms, the plant kingdom and the animal kingdom, but it focuses very heavily on the idea of the balance of nature.
And this is where the insert starts to sound a little bit like an environmental manifesto. It gives these very clear negative examples of how humans are disrupting this delicate balance.
For instance?
Cutting forests. Forests are part of the biosphere, obviously, but they anchor the soil lithosphere. If you cut the trees, you get soil erosion. The lithosphere literally washes away into the hydrosphere.
You're clearing land for agriculture.
Leads to the fast removal of soil. The text also mentions natural calamities, specifically the tsunami. It notes that parts of the Andaman and Nicobar Islands were submerged.
That is a terrifying thought, that land, actual land, can just disappear under the water.
And it connects directly to pollution and global warming.
Yeah.
Emissions from our cars and factories pollute the air, the atmosphere. The increased CO2 in the atmosphere leads to rising global temperatures.
Which melts the ice sheets on the lithosphere.
And the meltwater flows into the hydrosphere, raising sea levels. It's a chain reaction.
Let's link this to the exams. The biosphere must be huge in UPSC because it connects directly to environment and ecology, which is a massive part of the prelims paper.
It is. Look at the 2013 prelims paper. It asked about the characteristics of equatorial forests. The options were things like tall, closely set trees, a dense canopy.
And that's the biosphere in the torrid zone, right? Where you have high heat from the sun.
Yes, from the atmosphere and the lithosphere's position.
Wow.
And high rainfall from the hydrosphere and atmosphere interacting. When you have those conditions, you get this explosive growth of life. The intense competition for sunlight is what creates those incredibly tall trees.
But look at the 2025 mains paper provided in our source material. Question 4. It asks, how are climate change and sea level rise affecting the existence of many island nations?
This is the ultimate synthesis question. This is the final boss of Chapter 5.
So walk us through the answer using the 4 domains we've just discussed.
Okay. Step 1. Human activity, like burning fossil fuels, increases CO2 in the atmosphere. Step 2. This intensifies the greenhouse effect, causing global warming, a change in the atmosphere. Step 3. This warming causes ice sheets located on the lithosphere in places like Antarctica and Greenland to melt. That meltwater is added to the hydrosphere.
Okay, so more water in the ocean.
And at the same time, the existing water in the hydrosphere expands because warm water takes up more space than cold water. It's called thermal expansion. Step 5. The combination of these two things makes sea levels rise.
And the final impact.
The lithosphere of low-lying island nations, like the Maldives or Tuvalu, starts to get submerged. Just like the insert mentioned happened to the Andaman and Nicobar Islands during the tsunami, but this is a slow, permanent drowning.
And what happens to the life there?
Well, the biosphere, the people, the crops, the freshwater sources which get contaminated by salt water, it's destroyed. The nation ceases to exist.
Wow, so that one question from 2025 pulls from every single domain in Chapter 5.
Every single one. And if you understand the domains, you can structure your mains answer perfectly. Impact on land, impact on water, impact on air, impact on life. The examiner will absolutely love you for that kind of structured thinking.
This leads us perfectly to our integrated analysis. We call this the Simplified UPSC approach.
The biggest mistake I see students make is studying these topics in separate silos. You know, today's Monday, I study geography. Tuesday, I study environment.
But the Earth doesn't work like that. It's not on a schedule.
Not at all. A volcano is a lithosphere event, right?
Yeah.
But it spews ash and gas into the atmosphere. That ash can block the sun, cooling the Earth, which is an atmospheric change, which then changes rainfall patterns in the hydrosphere. The lava flows down the mountain and burns the forest, which is the biosphere. Everything is connected.
So in terms of exam strategy, what's the bottom line?
The insert provides the vocabulary. It teaches you what a strait is, what an isthmus is, what an archipelago is. You need these words to sound professional and precise in your answers.
Right. You can't write a mains answer saying, that skinny neck of land connecting the Americas. You have to say the Isthmus of Panama.
Exactly. Precision marks you as an expert. But the PYQs, the previous year questions, they provide the application. They ask you to use those concepts to solve problems or explain real-world phenomena.
I noticed the 2014 PYQ in our stack was about the urban planning of the Indus Valley. How does that fit in here? It sounds like history.
It is history, but it's a history that is completely rooted in geography.
Yeah.
Why did the Indus Valley civilization spring up where it did?
Well, because of the Indus River.
Hydrosphere,
Mm-hmm.
and the fertile floodplains around it,
The Lithosphere.
and the favorable climate that allowed them to grow surplus crops.
Atmosphere.
See, urban planning is essentially managing these three physical domains to support a dense biosphere, in this case a human population. They built sophisticated drainage systems, which is hydrosphere management. They use baked bricks made from the local soil, a lithosphere resource. It's all geography.
And even modern questions like that 2025 one on solar energy.
That links directly back to the heat zones of the Earth we talked about. Solar energy is most viable and efficient in the torrid zone, where the sun's rays are most direct. That's an atmospheric and astronomical concept being applied to modern economics and energy policy.
It really all does come back to the basics. You can't escape Chapter 5.
It is the operating system of the planet, and you need to know how it works.
We have covered a lot of ground, literally and figuratively. We've climbed Everest, dived into the Mariana Trench, we've felt the trade winds, and we've tracked the ocean currents.
We've seen that the Earth is this incredibly complex machine where the lithosphere, hydrosphere, atmosphere, and biosphere are constantly dancing with each other.
And the most important takeaway for our listeners.
That the balance between them is fragile, and that for a UPSC aspirant, understanding this balance is the key to cracking the exam. You aren't just memorizing facts, you are learning how the world actually works.
I want to leave you with the final provocative thought before we wrap up. We talked about the biosphere being this narrow zone of contact. We as humans are just one species in that zone.
But we are a species with a unique and, frankly, frightening power.
Exactly. Scientists are now talking about the Anthropocene, the age of humans. The idea is that we have become a geological force in our own right. We move more earth and rock, part of the lithosphere, through mining and construction than all the world's rivers combined. We have fundamentally altered the chemical composition of the atmosphere. We have filled the hydrosphere with plastics and pollutants.
It really raises the question, are we just residents of the biosphere anymore? Or have we effectively become the dominant force that is actively shaping the other three domains?
Are we the pilots of this ship, or are we just the unruly passengers who are wrecking all the furniture?
That is a question for the ethics paper, perhaps.
Indeed. Something to mull over. All right. That officially wraps up this deep dive into the major domains of the Earth. A massive, massive thank you to everyone listening. You guys are the reason we do this.
Yes, thank you for your time and your attention.
Now, for the final mandatory housekeeping, I'm going to ask you again because it really matters. If you found value in this deep dive, if you had that aha moment connecting the simple NCERT to the complex PYQs, please subscribe to the Simplified UPSC by PPP channel.
It helps us immensely. And if you are capable, and I always emphasize, only if you're capable, please consider supporting us on Patreon so we can keep bringing you this super useful content.
And don't forget, those free notes with practice PYQs are waiting for you right now on the public Telegram channel. Go grab them. They are free. Why wouldn't you?
And for the serious learners who want the full package, the organized videos, detailed notes, model man's answers, just DM us to join the private library.
Like, share, and comment. Tell us what you think. Keep learning, keep being curious, and we will see you in the next deep dive.
Goodbye, everyone.